Hello friends, welcome. Friends, in last video we discussed Newton's first law and Newton's second law. Today we discuss some important point of Newton's second law of motion and Newton's third law and some example. So our first question, write important points of Newton's second law of motion. Friends, now we have equation of Newton's second law is F is equal to dp upon dt. If mass is considered constant, so here we can write down F is equal to ma. Here m is a mass and a is a acceleration. But according to definition of the acceleration, we can write down change in velocity upon time. Means v2 minus v1 is a change in velocity and delta t is a time taken. Second number, if resultant external force acting on body is 0, means F is equal to ma, where suppose now we take first of all F is equal to 0, means we get acceleration a is also 0, means v is a constant, means velocity is constant, which is considered with Newton's first law of the motion. Third point, Newton's second law of motion give magnitude of force. Force is vector quantity. Suppose now we have three main component of the force: x component, y component and z component. Here Fx is a force is applied in x direction is equal to, we can write dpx upon dt, where px is a momentum of x component. Same way we can write down Fx is equal to max, where m is equal to mass and ax is a x component of the acceleration. Same way we can write down y component and z component. This means that when force is acting at by making angle with initial velocity, then component in direction of initial velocity will change, but perpendicular component will remain constant. Here one example are available. Look here, in case of projectile motion, gravitational force act in downward direction and horizontal component remain constant. Fourth point, equation F is equal to dp upon dt is equal to ma. Apply to point like object where F is resultant force acting on particle and a is acceleration produced. This law can be applied to rigid body or system of particle also, where F is a resultant force on system, A is the acceleration of system of particle. And 5 point, Newton's second law of motion is for object at given place force has relation with acceleration at a given instant. Thus acceleration can be obtained from force, but it cannot be determined from history of motion of object. Next question is, what is impulse of force? Write its unit and dimension. Friends, we know that from Newton's second law of motion, F is equal to delta P upon delta T. This delta T move left hand side. So we get F delta T is equal to delta P. The product of force and time interval for force is applied is called impulse of force. Look here. F delta T is called impulse of force. Means F delta T is equal to, we can write down delta P. Here delta P is a change in momentum. Means we can say that impulse of force is equal to change in momentum. The produce give change in momentum force is applied for short interval of time. Such large force produced is called impulsive force. In case of impulsive force, it is difficult to measure magnitude and time interval. Hence, impulse of force is obtained by measuring change in momentum. Friends, Newton's third law. One person is force are applied on the wall, and wall is also applied in opposite direction force. So both force are equal and both are in opposite direction. Look here. This person, both boxer are fight to each other. Look here. This person is force applied in negative x direction, and the wall is also applied same force in opposite direction. Means both force are equal and they are in opposite direction. It is called Newton's third law of motion. Means action and reaction both are equal magnitude and both are in opposite direction. Look here, this action and reaction both are same magnitude. According to Newton's third law, we can say that force always occur in pair. Force on a body A by body B is equal and opposite to the force of on body B by body A. So friends, this is the statement of the Newton's third law. During interaction between two, whatever amount of force is applied by first object or on second object, similar force is applied by the second object on first object. Direction of this force is in opposite direction. Means in short, we can say that action and reaction are force of equal magnitude but act in opposite direction. Hence, we any one force can be taking action force and another force as force of reaction. So from this law, it can clear that an isolated force do not exist. Force are always in pair, but these force act on different object and in mutually opposite direction. One example is when A spring is compressed. It is compressed due to force applied by hand. Compressing spring provides restoring force on hand which can be experienced on the hand. Friends, next illustration. The motion of particle of mass m is described by y is equal to ut plus 1 by 2 gt square. Find the force acting on the particle. Friends, now we have formula y is equal to ut plus 1 by 2 gt square. First of all, now we take a derivative with respect to time on both sides. Means left hand side we can write down dy upon dt. Here t is available, so dt upon dt is a 1, so only for u is available, and derivative of t square is 2t. 2 cut, so we get only for gt. So dy upon dt is equal to, we can write down u plus gt. But look here, dy is a distance and dt is a time. So according to definition of velocity, we can write down dy upon dt is equal to v. So v is equal to u plus gt. Friends, now we take again derivative on both sides with respect to time. So we, here left hand side we can write on dv upon dt. Here u is a constant and its derivative is 0. And here t is available, so dt upon dt is equal to 1. So we get only for g. But according to definition of acceleration, dv upon dt is equal to a. A means acceleration. So here we can write down small a, acceleration is equal to gravitational g. But formula of force F is equal to ma. Instead a we can write down g. So we get F is equal to mg. So equation represent acceleration motion under effect of gravitational force and show y component of displacement. Next illustration. A bullet of mass 0.04 kg moving with a speed of 90 meters per second enter a heavy wooden block and is stopped after distance of 60 meters. So what is the average resistive force exerted by the block on the bullet? Friends, first of all we assume retardation of bullet is small a, and now we have equation of motion. V square minus u square is equal to 2as. But here final velocity is 0 because this bullet is enter a heavy wooden block, means its final velocity is 0. So with the help of this formula, a is equal to minus u square upon 2s, where u is the initial velocity and s is the distance. Distance is available in centimeter. So first of all now we want to convert into meter. So 60 divided by 100 means 0.6 meter. S is equal to, u is equal to 90. So all these values are substitute. So we get minus 6750 meter per second square. According to Newton's second law of motion, F is equal to ma. Value of mass is available. Here mass is equal to 0.04 kg and acceleration is available. Here now we take value of acceleration is positive. So multiply 0.04 cross 6750, we get answer 270 Newton. Friends, now we have second method also available. You can try this method and find out answer. We discuss our last illustration. A batsman hits back a ball straight in the direction of the bowler without changing its initial speed of 12 meters per second. If the mass of the ball is 0.15 kg, determine the impulse imparted to the ball. Friends, mass is available 0.15 kg. Initial velocity is equal to minus 12 meter per second square. And final velocity is a 12 meter per second square. Here we assume initial velocity is minus x direction and final velocity is positive x direction. So a formula for impulse of force F delta T is equal to delta P. So delta P is equal to, we can write on m delta V according to definition of the momentum. Here delta V is a change in velocity, means final velocity minus initial velocity. So value of m is equal to 0.15. Final velocity is 12 and initial velocity minus 12 means minus plus. So 12 plus 12 means 24. 24 cross 0.15. So we get 3.6 Newton second. So direction of impulse is from batsman to bowler. Friends, all this question and illustration you write in your notebook and prepare it. Thank you.